Fort Bend Tutoring. Math made easy. Personalized math tutoring is the solution.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring. Today we will be discussing solving quadratic equations using the square root property. Let's see what's going on here. All right, ladies and gentlemen, when you're using the square root property, you're solving a quadratic equation, meaning that the highest exponent on the variable is 2. The highest exponent on the variable is 2. And we can isolate, get by itself, that part of the equation that's being raised to the second power. So, for instance, in problem number 1, I have x squared equals to 36. In other words, x to the second power is equal to 36. What I want to do, ladies and gentlemen, is I want to first of all make sure that the part that's being raised to the second power is by itself on one side of the equal sign. In this case, it is. Then, in order to solve for it, you'll be taking the square root of both sides of the equal sign. So, in order to get rid of that square here, I can say the square root of x squared is equivalent to plus or minus the square root of 36. So when you're taking the square root of both sides of an equation, the other side of the equation, you have to have the plus or minus symbol. The reason for that, ladies and gentlemen, is because the negative version squared and the positive version squared will also give you 36, and I'll show you that once we get our answer. So the square root of x squared is just x. Remember that the index on a square root is 2, and basically what happens is these 2's here will cancel out to give you x equals to plus or minus 6. So therefore, if I was writing my answer in a solution set, and once again, my braces suck, so let me see if I can fix my brace. There it is. I'll end up with negative 6 as well as positive 6 as my solution here. And that's going to be my answer. Now to plug this in, I can show you why that'll be the case. For instance, if I replace x with negative 6 squared means negative 6 times negative 6, and therefore that makes a true statement because negative 6 squared is 36. If I were to plug in positive 6 squared is also 36. So either result will work, therefore your solution is both answers. And also that is why it justifies us having the plus or minus symbol when we're using the square root property. So once again, the square root property, you isolate the part that's being squared, and then when you take the square root of both sides of the equal sign, the other side of the equal sign that's not being squared, please put a plus or minus symbol in your process. And that's number 1, ladies and gentlemen. Let's look at problem number 2. In problem number 2, we have p squared minus 50 equals to 0. P squared minus 50 equals 0. So in this problem, your first step is to isolate the part that's being squared, ladies and gentlemen. So here, I'm going to add 50 to both sides of the equal sign here. The 50s will cancel out. I'll bring down p to the second power, which equals to 50. And now, in order to get rid of that p squared, ladies and gentlemen, I'll take the square root of both sides, remembering that on the right side of the equal sign, I'll need to put a plus or minus symbol. So this is how I begin, taking the square root of both sides of the equal sign and remembering to put the plus or minus symbol on the other side of that equal sign there. The square root of p squared, ladies and gentlemen, is p. And what I'll do on the right side is I'll simplify the radical. So here, because this is a square root, I'm looking for the perfect square that'll go evenly into 50, and that would be 25. So I can break this down into the square root of 25 times 2, and then from there, I'll be able to say the square root of 25 is 5. So that leaves me with a result of plus or minus 5 square root of 2. If your teacher prefers you to expand it, then you can write a solution set that reads negative 5 square root of 2 and 5 square root of 2 as your solutions, ladies and gentlemen. So remember, it's plus or minus on that right side of the equal sign when you're working these problems out. Let's look at this one again. Here we started out with number 2. It's p squared minus 50 equal to 0. I added 50 to both sides in order to isolate the part that was being squared. Then you'll take the square root of both sides, and when you do that, you always put a plus or minus symbol on the right side of that equal sign. From there, I'll then simplify the radical. I found that 25, a perfect square, goes evenly into 50. Then taking the square root of 25, which is 5, that comes outside of the radical symbol and leaves me with just the 2 inside. So then, expanding that solution of plus or minus 5 square root of 2, I can write it as negative 5 square root of 2 and positive 5 square root of 2, and that is my solution to that problem. Moving along, we have problem number 3, ladies and gentlemen. This is the quantity of x plus 8 squared equals to 9. Remember, your first step is to isolate the part that is being squared. Here, instead of it just being a variable, it's a quantity. I have x plus 8 being squared. So I have that quantity squared that contains my variable. I want to get that part isolated. So once again, this x plus 8 to the second power, I need to get by itself, and it is. So from there, I'll go ahead and use the square root property. So I'll be taking the square root of both sides of the equal sign. So here you'll see I have the square root of x plus 8 squared equals to, and on the right side, it will be plus or minus the square root of 9. The square root of 9, ladies and gentlemen. On the left side, the square root and the square will cancel out to give me simply x plus 8, which now equals to plus or minus 3. From here, ladies and gentlemen, I'll be solving for x by subtracting 8 to both sides. So when I subtract 8 to both sides, my 8's cancel out on the left side. I'll bring down a negative 8 plus or minus 3. And then from there, you can actually end up with 2 solutions this way. Because we're just dealing with numbers here, we can actually combine this together, and I'll end up with 2 results. One result will be that x is equivalent to negative 8 minus 3. The other result is that x is equivalent to negative 8 plus 3. And then we'll get both solutions taken care of this way. So here on the left equation, I have x is equivalent to negative 11. And on the right equation, I have x is equivalent to negative 5. So your 2 solutions here, ladies and gentlemen, will be negative 11 and negative 5. So let me get my brace working here. You'll please forgive me for that jacked up brace. And that's going to be my result here, negative 11 and negative 5. So recapping this, ladies and gentlemen, in problem number 3, I started out with the quantity of x plus 8 raised to the second power, which equals to 9. I will then take the square root of both sides of the equation, remembering to put plus or minus on that right side when I'm using the square root property. Remember, we have to include the negative and positive versions of the right side because both squared will give me a positive 9. So from there, I bring down my x plus 8, which is equivalent to plus or minus 3 once I've taken the square root of 9. And then I'm subtracting 8 to both sides to solve for x. Once I have that done, notice that I have negative 8 plus or minus 3. So therefore, these being numbers, I can combine these together in 2 different equations. One, I'll have x is equal to negative 8 minus 3. The other, I'll have x is equivalent to negative 8 plus 3. Combining my like terms there, I end up with negative 11 and negative 5. And there you have my solution set written in ascending order because I like to have my solution set from least to greatest. All right, let's check out the next one. Problem number 4, ladies and gentlemen. In problem number 4, I have the quantity of m minus 6 squared equals to 27. So once again, ladies and gentlemen, I want that binomial that's being squared isolated on one side of the equal sign, and it is. So what I'll do in problem number 4 is I'll take the square root of both sides of the equal sign. This is going to be the square root of m minus 6 squared and plus or minus, always remember to do your plus or minus symbol, the square root of 27. On the left side, my square root and square will cancel out to give me m minus 6, which is equivalent to plus or minus, and I'll expand 27 into 9 times 3 because the largest perfect square that goes evenly into 27 is 9. From there, I'll be bringing down my m minus 6. This is going to be equivalent to plus or minus 3 times the square root of 3 because the square root of 9 is 3, and therefore I can bring it on the outside of the radical there, outside of that square root sign. Then solving for m, I'm adding 6 to both sides now. So my 6's cancel out, and that leaves me with m is equivalent to 6 plus or minus 3 times the square root of 3. So, writing my solution set, ladies and gentlemen, it'll look like this. Let's take my time on the brace there. It's still jacked up. We'll end up with 6 minus 3 times the square root of 3, and I'll also have 6 plus 3 times the square root of 3, ladies and gentlemen, and that is going to be my solution there. So notice that I'm writing my solution in ascending order, and since I'm subtracting 3 times the square root of 3, I'm going to put that term first, and then the other one will be larger, of course, because I'm adding 3 times the square root of 3. And that concludes problem number 4, ladies and gentlemen. We started out with the quantity of m minus 6 squared equals to 27. I then took the square root of both sides, making sure that I have the plus or minus symbol on the right side. I'm then going to simplify the radical by expanding this into 9 times 3. I add my 6 to both sides after I take out that square root of 9, which is 3. So that leaves me with plus or minus 3 times the square root of 3. And then I end up with a result that is m equals to 6 plus or minus 3 square root of 3. Once again, if I'm writing that out expanded, it will be 6 minus 3 square root of 3, and also 6 plus 3 square root of 3. Some teachers will accept this previous form, ladies and gentlemen, so this form may be okay for you. It all depends on your teacher and whether or not they want to expand it or not. All right, that's problem number 4. And that's going to do it for our introductory lesson here today, ladies and gentlemen, that dealt with solving quadratic equations using the square root property. Thank you very much. This is Mr. Witt, and once again, please rate, comment, and subscribe. And of course, if you find your way on Facebook, please like our Facebook page. It is Fort Bend Tutoring on Facebook. Thank you very much. Bye-bye.